before I move on to a more complicated example. I thought I would touch on a point that I made in the previous partial fractions 1 video, and I wasn't able to kind of completely complete. And that was just the idea of how do we solve this equation right here. And just a little bit of review of how we got here. And if you don't know how we got here, this looks completely unfamiliar, you should watch the partial fractions 1 video. But we said that this rational expression can be written as the sum of these two simpler rational expressions. And when you add these two fractions or these two expressions, you get this. You just found a common denominator, and then you multiply this times the denominator of the other one, multiply this times the denominator of the other expression. And we got this here, and then the denominators are the same, so now we just have to set the numerators equal to each other, and that's where we got this right here. And I had mentioned in the last video that there's two ways to solve this problem. And the fast way, and then the way that at least I was taught when I was in, I forgot when, 8th or 9th grade. And I suspect that it's still the way that it's taught in a lot of schools. So I wanted to teach you that way, just so you don't do it the other way. And some teachers are very particular about how you do a problem, even though that's completely correct. So I thought I would at least expose you to the way that your teacher or your school might want you to do it. And it's also an interesting way, and it might be relevant to solving other types of problems. So just as a review, in the last video, to solve this, I just set x to be values that would make the a or the b disappear. So if x equals minus 5, I picked minus 5 because it makes this expression 0, so it cancels out the a. You're left with minus 5 plus 3 is equal to 0 plus b times minus 5 minus 8. That's exactly what we did in the last video. And if you just solve for this, you get what b is equal to 2 over 13, if I remember correctly. And then I picked x is equal to 8 to make this equal to 0, and that made us 8 plus 3 is equal to a times 8 plus 5 plus, now this expression would be 0, and then you would just get a is equal to what? It's 11 over 13. And then we were done. And then we knew what our I guess, decomposed fractions are, or I guess the partial fractions of this larger one. I don't know exactly how that terminology should apply exactly, but you get the point. The other way to solve this, and this is the way I was exposed to it, let me write that in green to show that I'm just continuing this part of the problem, I'm just solving it a different way, is to multiply out this expression. So just to write out the whole thing is x plus 3 is equal to, now I'm going to multiply it out, ax plus 5a plus bx minus 8b. And then to group the x terms and then the constant terms, and you get x plus 3 is equal to ax plus bx plus 5a minus 8b. Notice I just grouped the x terms and I grouped the constant terms. And then you could say x plus 3 is equal to, we can factor out an x here, a plus b times x plus 5a minus 8b. And then the realization you have to do at this point, you say, okay, if I'm adding these two things up and I get this, a plus b, so all of the things that involve x are right here. These are all of the things that, so this has to be equal to this. Right? There's no way that I could substitute some type of a's and b's here that would somehow contribute to the 3. And likewise, the constant terms have to add up to the 3. And you use that insight to essentially set up a system of equations. So you say, well, a plus b, that's the coefficient on the x term on this side. Well, that has to be equal to the coefficient on the x term on that side. And the coefficient on the x term right here is 1. It's not written, but it's implicitly 1 times x. So you can write down the equation. Let me do it in that light blue color. A plus b have to equal 1. And then the constant terms have to add up to 3. So you could write 5a minus 8b is equal to 3. And then you have a system of two equations, two unknowns, and you solve it like the way you always learn to solve it. And let me do it right here. So there's a couple of ways you could do it by substitution. You could multiply both equations. Actually, an interesting thing, let's multiply this top equation by 8. So then you get 8a plus 8b is equal to 8. Right? I just multiplied all the terms by 8. And now we can add these two equations. And I did that so that these cancel out. So 8a plus 5a is 13a. 8b minus 8b, that's 0, is equal to 8 plus 3 is 11. And then you get 13a is equal to 11. A is equal to 11 over 13. And then you could use this information and you substitute it back into this. And that original equation, I mean, you could substitute it back into 8a plus 8b is equal to 8, or you could substitute it back into a plus b is equal to 1. And you get 11 over 13 plus b is equal to 1, or b is equal to, well, another way to write 1 is 13 over 13 minus 11 over 13, and that's 2 over 13. So you can see there's a huge difference in the amount of time and, frankly, the amount of errors you can make when you do it this way. But this is the way, at least in Louisiana in the late 80s, it was taught. Anyway, actually, I'll leave you in this video, and in the next video, I'll start a more complicated problem.